Correct. Yes. So another way to kind of describe that thing here, remember how we did all that mapping business yesterday where I said like x, y, and then an arrow, and then it goes to something new, right, with the translations, and we did the plus and the minus to x and all that. Well, I can do the same kind of thing here. If I'm going to do, let's say this is over the x-axis. Okay, so remember, over the x-axis, x stays the same, y changes sign. So how could I write it this way, do you suppose? What would it look like if x stays the same and the y changes its sign? We make that into a little formula here. Yep. Right, which would just be negative y, right? So that's another way to describe it. Okay, and they might ask you to do that at some point. So I would write this down if you haven't yet. So over the x-axis, xy goes to x negative y. And then over the y-axis, it's the same kind of thing. xy. Except this time the x changes sign and y doesn't. So it looks like that. Okay. Now I'm going to caution you a little bit. These two things are just when you're going over those axes, okay? We're going to reflect over a whole bunch of other kinds of lines, not just the axes. So these won't work for other types of reflections, but if it's over an x-axis or a y-axis, you're good. You can use those, okay? Because what I'm going to do next is a little different. So you might see something like that. Reflect the point 2, 3 over the line y equals negative 1, and then what are the new coordinates of that? Now, some people can do these in their heads too. Okay, if we do this enough and you're feeling comfortable with that, I'm okay with that. But if you're feeling at all uncomfortable, a little unsure, especially if it's a test or a quiz or something, draw the stupid thing out and actually take a look at it, okay? Doesn't matter if it takes you a little extra time. But in any event, so for this one, so we're going to start with the point 2, 3. So 2, 3. So here's our little point. And we're not reflecting over an axis. We're reflecting over the line y equals negative 1. Well, where's the line y equals negative 1? Yeah. Exactly. It's a horizontal line at negative 1. It's down here. So that's the line of reflection. Not the x-axis, not the y-axis, but that line right there. But concept's still the same though, right? You take this point, count down to that line, 1, 2, 3, 4, and then I got to go 4 on the other side of it. 1, 2, 3, 4. So my image is all the way down there. Okay? And what are the coordinates of that new point? Our first point was 2, 3. But where are we at now if I went all the way down that far? 2, negative 5. Okay? Now, just like going over the x-axis, though, notice how the x-coordinate stays the same. Right? Still 2. However, the y-coordinate didn't just switch signs, right? We had to actually count it out and see how far down it went. Okay? Vertical lines, same kind of a thing. So I'll do one of those with you here too. So if we like reflect a point, I don't know, negative 1, 3 over the line x equals 2. See if I got enough room here. Sort of. I'll count by 2s. Okay, so there's my x-axis, there's my y-axis. So my point -1, 3 is going to be sitting right here. And I want to reflect it over the vertical line, x equals 2. So that's here. Okay, so same thing, right? Just count over. So every box is equal to 2, so how far over am I going to get to that line? 3, so 3 on the other side of it. 1, 2, 3 is right there. And so what are the coordinates of that image then? That's right, 5 what? Yeah? 5, 3. No, it's all right. So again, this time I'm going over a vertical line, kind of like the y-axis. My y value stays the same, but the x changes. But I gotta count it out still though to see where it's at. Okay. So, are we all feeling comfortable? Any vertical, horizontal line reflections were okay. Yeah. Okay. Because the next thing is what if that line of reflection is tilted, not just vertical or horizontal? It makes the process a little bit more difficult. Okay. Same concept though. Okay. See how far away from the line of reflection you are? Same amount of distance on the other side of it. Okay, so keep that in mind as we do this. Because while, yeah, we'll get a little more difficult, that's still kind of the basis of what we're doing here. And I won't make these tilted lines terribly difficult for you, and I'll show you how you can kind of get around any difficulties you might have with them. Mm-hmm. Guys, stop it. Both of you. You're both in the wrong. Okay, so I'm going to draw a triangle DEF. Let's put it maybe down here. Okay, and we're going to reflect this over the line y equals x. Actually, well, I got to put some scale on here first. But can anybody remember what the line y equals x looks like? So, what does that look like? Yeah.
A diagonal line.
Yeah.
With a 0.
It goes through the origin, and it's a diagonal line, and its slope is what? 1, right? It's a slope of 1, a y-intercept of 0. So that line of reflection is going to be just like this. Okay? It makes a 45-degree angle with both axes. Does that make sense? So it's like exactly halfway between the axes and straight up. Okay, so now, like we talked about, to reflect this thing, we got to figure out how far each one of these points are to that line of reflection. And it's not just a simple counting it up or counting it to the left or right or whatever. You got to count diagonally towards it, okay? Because I don't know if you've noticed this yet, but as we're making these, like, we're figuring out how far away things are from lines of reflection, we're actually coming at those lines of reflection perpendicular, right? Did you guys notice that? Every time we were counting to a line of reflection, it was always going towards it perpendicular to that line. Same thing here. So I got to figure out, how do I count how far away I am to this line going perpendicular to it? Well, the nice thing is, if I have a slope of 1, and I want to count perpendicular to it, I have to go with a slope of what? -1. Whoever said that, good job. So -1, so I got to count kind of like this. So here's D. So if I'm going to go perpendicular to this line, I got to go like that towards it. You zoom that in a little bit so you can see that. Okay? So see how this line goes through the corners of all those boxes? If I do that but go this way instead, I'm going perpendicular to it. Okay? So instead of counting how many like widths or heights of those boxes, just count how many diagonals of those boxes you've done. And it's the same idea then. So to get from D to the line of reflection, I had to go one diagonal box, right? So go one diagonal box through it on the other side. One more diagonal box. Boom. There's the reflection. There's my D prime. Okay, so let's try the same thing with E. Okay, so I'm going 1, 2 diagonal boxes to get to the line of reflection. So then 1, 2 onto the other side. Boom, there's E prime. And then F. So this one, I got to go 1. And I'm actually tracing the same line this time, right? 1, 2, 3, 4. So 1, 2, 3, 4. There it is. It's up there. It's not a translation. Nope. It is a reflection still. Okay? And if you turn your page, you might be able to see that reflection a little bit better. If I turn the page like that, do you see how that reflection worked there? Still doing the same thing, right? It's just our reference frame is changed. We've rotated a little bit, but it's still the same idea of how you go about doing it. Yeah.
Is it supposed to be trapezoid every time?
Not every time, but a lot of the time it does. Yeah. So, anywho, so that's how you can pull off one of those reflections. Now, real quick, there is a connection with these coordinates again, though. So what I'm going to do is I'm going to give you the coordinates of D, E, and F, and then you write down the coordinates of D prime, E prime, and F prime, and take a look at them and see if you notice anything that jumps out at you. So D was at 0, -2. E is at 5, -1. And F is at 7, -3. I messed up. Oh, this is at 5, -3. And this is 3. Yeah. It's a 3 and a 5, not a 5 and a 7. Okay. Anywho. D prime, E prime, F prime. Okay, so write down the coordinates of those real quick and then see if you can figure out what the heck's going on with these coordinates. Oops, somebody figured it out. Gabby? Yeah, X and Y just swap, right? When you go over the line y equals x, they just swap. So if you can remember that rule, you don't have to draw these either. Okay, over the line y equals x, easy. I'm just going to switch them. So let's make a rule for this one too. Anytime you reflect over y equals x, xy should go to what? Yx, right? What? Oh, yeah, we don't have to write it that way, though, if we don't want to. This works for all.